What's up, math scholars? We're doing 7-1 today, properties of exponents. I did give you a property of exponent sheet. We're only doing the first 3 properties today. You will need paper to kind of supplement those notes because we're going to be doing more practice problems than just what you're seeing on the paper. So who's excited that it's Monday? All right, so let's take a peek at the 3 properties you'll be talking about today. These are properties of exponents, how you deal with exponents if you see the exponents. So first one we're looking at together, you have this on your sheet, is product of powers. Basically what will happen is your base, like this base A, will remain an A. That will not change. But the M and the N, they will add together. So looking over at this example, if you have B to the 2nd power and you have B to the 5th power, what do you think will be your answer? We have to add the exponents. B to the 7th. There you go. Oh boy, that was interesting there. Oh boy. There, much better. My smartboard was being interesting for a second. Okay. Now, one thing to keep in mind throughout today and this whole chapter is numbers behave differently than exponents. See the 5 and see the 9? They're not going to behave like exponents. You're not going to add the 5 and the 9. What do you think you would do with the 5 and the 9? Yeah? Multiply. Very good. So the 5 and the 9 will multiply to give me 45. But now the x squared and the x third will do the properties of the exponents on them. So what would that be? For the 5th. Very good. You would add them. So treat normal numbers normally, but treat exponents with the exponent properties and add them. So that's the first one. It's called product of powers, when you add your powers. All right, our second one we're doing today is power of a power. This time it kind of talks you through it. When an exponent or a number is raised to a power, you're going to multiply. So when you see them separated with the parentheses, you're going to multiply them. If I have d to the 5th raised to the 3rd, what do you think the answer would be? Multiply them. 15. Yeah, d to the 15. All right, so this one looks a little interesting. What's going to happen here is you're actually going to have to distribute this into everybody. So -3 is going to have to be raised to the 3rd power. Let me write that out. The x squared is raised to the 3rd power. Those will multiply. So that'll be x to the 6th. And then the y to the 4th will be raised to the 3rd power. Those will multiply. So that'll be y to the 12th. I will want to figure out what -3 to the 3rd is. Do you guys know? -3 to the 3rd. You can use parentheses if you want, but you don't have to because it's odd part. Let's do it mentally. What's -3 times -3? Positive 9. And then what's a positive 9 times -3? Good, -27. So my final answer on this one is -27, x to the 6, y to the 12. Sorry, I went on my box. They don't leave you much room in these boxes, do they? It's a disappointment. And then our last property we're touching on today is power of product. The other properties we'll save for other days. It's when an exponent is outside the parentheses, everything inside is raised to that power. We kind of already did that. So the m basically goes to everybody on the inside. So what do you think the answer to this first one is? X, y, z to the 3rd. We'll distribute it to everybody. We will get x to the 3rd, y to the 3rd, z to the 3rd. Have you done these in the past or not?
No.
No? Okay, awesome. First time ever. We do so much reviewing in math, it's rare that you see something for the first time ever. Everybody likes learning new things too. Okay, so this one over here, we're going to distribute this 3 in. You want to, gosh, I don't know why my smartboard is being weird today. All right, we had to pause and realign our board. I think we're back in business. So we're going to take this 3. We're going to do 5 to the 3rd. What's 5 to the 3rd power? No, 5 to the 3rd power is 5 times 5 times 5. 5 times 5 is 25. Times 5 is 125. And then we're going to do b to the 3rd, c to the 3rd. Right. That concludes everything we're going to do on the power sheet today. Now we're just going to do a whole bunch of example problems to get used to what different types of situations they could throw at you. We'll do a few together, and yeah, I'm seeing a board buddies in our future. Probably. All right, we will do these 4 together and then maybe call some board buddies up. So part A, we have 7 to the 3rd, and then we have 7 to the 5th. Raise your hand if you think you know what will be the answer. Ken? So we're going to actually leave it a 7. The base remains a 7. It's just the powers you have to deal with. To what power?
8.
No? Oh, yeah, I'm sorry. It is 8. Sorry. I was having a moment. So you do 5 plus 3, you get 8. Yep. Part B, we have a little bit of a challenge here because you cannot see the power of this 9 that my fingers point to. I'll point to it on the arrow in case we have video watchers. What is the power of that 9 living right there? Cassian? It's a 1, yeah. So that's a case where 1 can be invisible in math. I always talk with my Algebra 2 kids. Do you actually know 1 can be invisible in math? 0 can be invisible in math? Did you know 2 can be invisible in math? And 10 can too. Do you want to see when 2 can be invisible? Square root of 16. You might not realize it, but a square root of 16 has an invisible 2 right there. It's a square root. You'll learn about cube roots and 4th roots and 5th roots on up, but square roots have invisible 2's. That's just advice, tidbits of knowledge for life. All right, so we'll be 9 to the 11th because you'll do 1 plus 8 plus 2. Everybody okay with that one?
Yes.
Good? Okay. On this one, I think we have the same exact concept happening. What's the power of this negative 5? A 1. So what do we think the answer will be? Negative 5 to the 7th. Very good. Yes, I would definitely have the parentheses, and here's why. If you're doing a problem later today and you have maybe negative 5 squared and you want to use your calculator, it's absolutely 100% necessary to have the parentheses when you use the calculator so that you can get a positive answer in that situation. So just get used to having them. All right, and then D at the bottom, Caspian? X to the 7. Okay, people at home, pause your video, try these 2. We're going to send up board buddies. We definitely had the conversation with more than one person. We definitely had the conversation a second ago with more than one person on do we want to add the 5 and 3 or do we want to multiply the 5 and 3. So look at your property sheet really closely. When you have the exponents right beside each other, I call these guys next door neighbors because they're literally right beside each other. Next door neighbors will multiply together. So the 5 and the 3 will multiply. The 2 and the 5 will multiply. So good work to the people that came up to the board. I actually want to do these 2 together because I looked at part D and it looks very, very tricky. What do you think the answer part C is? I don't think that should be a problem. X to the 8th. Good job, Jagger. Now let's talk D. It might be very tempting to think that you're going to want to distribute these powers in, but you cannot do that. And here's why. If this is a sum, it has to be a product for you to distribute it in. So you're actually just going to keep the y plus 2 as is, and you're going to multiply the 6 and 2. So what's that answer? Good job. All right, we're going to call up some board buddies for this one as well, so pause the video and try it. Okay. Here's what I normally find myself saying. If the numbers are able to calculate, like in your brain, go ahead and calculate them. But I can't do 24 times 13 in my brain, and I certainly can't do 24 to the 8th power in my brain. So I think their intentions, they being the people that wrote this problem, their intentions is just distribute the property. Do the property. So it's 24 to the 8th. 13 to the 8th, and then leave it. I think that number would be ginormous. It might even be in scientific notation if you would type it into a calculator. So just demonstrate you know how to use the property. Now this one, 9 squared, that's a small enough number you can do in your head. 9 times 9. So I would go ahead and write the 81. Then it would be x squared, y squared. So that's looking good. Good job. Let's do this one together. You're going to distribute that squared in. What is negative 4 squared? Negative 4 times negative 4. Positive 16. And then what about the z part of it? Z squared. All right, I want to take this moment for a public service announcement about your calculator. Can you dig your calculator out real quick? I would like you to try 2 math problems in your calculator. So, your calculator, here's how it works. Everybody in the room agrees that -4 times -4 is a positive 16, right? I want you to type it in like this and see what your calculator tells you. Yeah, so that's not technically correct, right? -4 times -4 is a positive 16. So if you type it like this, here's why your calculator is getting it incorrect. It's your calculator squaring the 4, getting the 16, then applying the negative sign. So if you want the calculator to do a problem correctly, that's where those parentheses become important. That's what I was talking with Jagger. Type it like this now. Right. So it's very, very important that if you're taking a negative number and squaring it, or taking it to the 4th power, or the 6th power, any even power, to have that parentheses in place, okay? Everybody good with that? All right. You'll hear that every single year, because it's important. You want the calculator to give you the right answer, not the wrong answer. Aha! This is a little bit different of a problem. Let's do it together. What's different about this problem is the squared is being applied to a positive 4 and a positive z. And then the negative is kind of like an afterthought. It's going to get applied at the end. So what is this 4 squared going to give me? And what's this z to the 2nd power going to give me? And then you're going to apply the negative at the end. So these are very different problems because of the placement of the parentheses. Okay? We're going to send up 8 people and see if they can figure this one out. All right, so Ray said it best. Did this problem use all 3 properties? It did. So the one property that we saw was taking this exponent and rainbowing it into everybody. So the 2 got squared, which gave us 4. And the second property was taking this 2 and 3 and multiplying together, giving us x to the 6th. And finally, the third property is taking the 6 and the 4 and adding them to become the 10. This is where it really starts getting challenging, is all 3 of the properties appearing in one big problem together and knowing what to do when. All right, go ahead and check this answer. All right, we've arrived at your graduation problem. Try it all by yourself. Okay, they're working on solving this. I'm going to kind of explain it to you guys in the video. I would deal with my parentheses first. So I would take this 4, do it to the 4th, apply it to the 2. So I'm going to calculate out 2 to the 4th. 2 times 2 times 2 times 2. You can do that in your head. It's 16. Then I would multiply the 5 and 4 together. That's going to be d to the 20th. Out here, I still have this 6d squared just hanging out. Now, one thing to keep in mind is there is a little dot right here, and there's a little dot right here. So I can rearrange the order of this thing and kind of put people together that I want to be together. I want the 6 and the 2 to the 4th to be together, 2 to the 4th is 16. And I want my d squared and my d 20th to be together. I would multiply the 6 times the 16. What is 6 times 16? 96. And then I would add up those 2 separate d's to get d to the 22nd. All right, so tonight you're going to get into varsitylearning.com. Varsitylearning.com. Look on the calendar for 7/1. Thanks for watching our video.